Hey everybody, today we have a problem that's in the form of a number summed with its reciprocal is equal to a complex number. Now what I'm going to do is I'm going to rewrite this in an equivalent fashion. We're assuming x doesn't equal to 0, and it certainly can't. But if you multiply it through by x, you would end up with this equivalent quadratic 7 plus 5i quantity times x, and then plus 1 equal to 0. So you could use the quadratic formula, I suppose, to try to solve this and get your complex solutions. And let me make sure I did this right. X times this, then x times this brings it over, and then x times 1 over x is certainly just 1. So I think that's right. So one approach is to try to solve this, then actually raise it to the fourth power, then also take its reciprocal and raise it to the fourth power. Okay, it turns out there's an approach involving algebra which is not uncommon on these types of impossible looking problems. So we never will know what x is, but we can actually solve this the approach here. Okay, now an important identity that you may have surmised here, it would be important, is if you sum up a number and its reciprocal and square it, you get this right here. This is just the famous form 2a squared, or a squared plus 2ab plus b squared. Now notice this part right here is just 2, right? So this would be equal to, we can rewrite this a little more in a friendly fashion, a squared plus 1 over a squared plus 2. Okay. Again, this is a natural thing to be curious about since the given is in more or less in this form. Okay. So let's keep going. Yeah, the rest is just you literally use this thing twice, as you can see right here. Okay, notice that if you subtract 2, you could subtract 2 over to here, and you'd get exactly what this is squared. Okay, or it's this statement right here is just equivalent to using this identity when a is equal to x squared. Okay, when a is equal to x squared, this is what would happen. Okay, but guess what? We have it again. You see, we have something in the same form. Okay, and so this time it would be the same thing as having a is equal to x. So I hope you guys see that we actually applied this result twice for this statement right here. Okay. Now, so at this point we have what we're interested in. We have x to the fourth plus 1 over x to the fourth equals to this underlying object right here. Okay, but guess what? We are given x plus 1 over x. X plus 1 over x is given to be 7 plus 5i, right? X plus 1 over x, 7 plus 5i. So that's exactly what I do here on the next line. And I won't spend a tremendous amount of time here. Just remember, of course, that I squared is equal to -1. The imaginary unit. Okay, it's imaginary because no real number squared is equal to something negative, right? And so utilizing this fact in this arithmetic, you end up with this statement here. Okay, and again, you can expand this out, and this is what you'll get. Now, let's see, what does this end up being? This is the same thing as, okay, this would be 49 minus 25, which is what, 44. So yeah, so we would end up 24, and then you would end up with 22, I believe, right? So this is the same thing as 22 plus 70i. And you guys verified, I'm pretty sure I got that right. 70i quantity squared minus 2, right? Okay, and again, the way I did that was just 49 minus 25 is 24. There's a 2 in there, so 24 minus 2 is 22, and then the 70i. And you can see where the 70 comes from. That's just 2 times 7 times 5. It's part of that identity too, the a plus b squared identity. Okay, now y'all, I won't bore you with the details on this. When I expanded this out, it's not particularly difficult, but I'll just write down the answer and see if you get the same thing I got. I got minus 4418 for the real part. Minus 4418 for the real part, and then plus 3080 I. And that's complex number, and that's the answer I got. Okay. 4418 minus 4418 plus 3080I. Okay. So again, I kind of like the problem. It's a slightly challenging problem in the sense sometimes you're unaware that you can apply something more than once. I've seen students who will work something, they think, oh, we've already used this. But you see, we actually had to use it twice. We had to use it twice here to get the desired result. Once right here, then once right here. And again, think of the two being subtracted from this side right over here, and you get a squared plus 1 over a squared. So that's it. That's the answer. Thank you for viewing.